Right, we're going to finish chapter 17, which is weather forecasting and a little bit about climates. So weather forecasting is interesting because it's probably the most fluid aspect of science, meaning we don't really know everything about it, but we've come a long way in the last probably 100 years. So weather forecasting is based upon mathematical models of the atmosphere, and billions of calculations are done in order to make predictions using supercomputers. Honestly, the forecast in your book, it's going to say it's fairly accurate up to 3 days, but we all know there's a 100% chance of rain 3 days from now and then no rain at all. So I would say a day in advance. You're probably certain that tomorrow this is what the weather will be like. Now, there are major uncertainties with the weather forecasting because, one, we just really don't have the technology to connect small and large scale events yet. Remember, weather is a global thing. Even though weather affects you locally, we're looking at a global analysis, and that's really not something that we've quite figured out to a T. And ultimately, we don't understand how oceanic influences change these calculations, and until we better understand them, we're really just going to have weather forecasting that is relatively accurate and not absolutely accurate. So climate, as opposed to weather, is the composition of larger weather patterns occurring over a number of years. So think weather taken every day for 30 years, and that's climate. So this is where people get sticks in their sides about climate change, because it's like, well, the weather here is just like it's always been. But local weather is not the same as climate. And so when you're talking about climate change, we're looking at a bigger picture, whereas weather and where you are right now is a piece of the puzzle. It's not the entire puzzle, and looking at a single piece of a puzzle doesn't tell you what the entire puzzle looks like, just like weather where you are right now does not tell us what climate is like everywhere. So climate's important because it determines a factor in the types of plants and animals that live in that location, the types of houses we build, the lifestyles we live. Climate influences the shape of the landscape, the types of soil that exist there, and what agricultural types and productivities can occur there. There are climate groups we're going to talk about, and the two primary factors in climate groups is the intensity of the incoming solar radiation, so whether or not it's getting direct sunlight or it's getting that sunlight that's kind of dispersed at an angle, and then the number of daylight hours. So the climate zones we're going to talk about are going to be defined in respect to yearly temperature averages. So the tropical climate zone is near the equator. It's this green band here that goes over Central America, South America, Africa, and Indonesia, India. It's near the equator, receives the most solar radiation, so it's very hot there. It tends to be where your deserts and rainforests are. The polar climate zone is on the north and the south pole, there in purple. It gets the least amount of solar radiation, so it's colder. At some points during the summer, there's constant daylight, so 24 hours of daylight. But in the winter, there will also be constant darkness, where it's dark for 24 hours, and people have to get up and go to work and have to go to school, and it's completely dark. Now, the temperate climate zone is a mixture of the both. The temperate is the lighter blue, the southern part of Africa, Australia, the southern part of South America, as well as most of Europe and Asia, and then obviously the United States. So even when it's hot here in Texas and it's 110 degrees outside, we are still considered a temperate climate zone. So it's going to end chapter 17, and then you are going to watch the first portion of chapter 18 to finish out your day for today. Make sure you finish chapter 17 notes and submit them when you